solving equations that have fractions in them. Solving this equation, even though it's a two-step equation, actually it would end up probably being a three-step equation, is going to be a little difficult with having to now take this half and deal with that. So there's a way to get rid of fractions at the beginning and then be able to solve your equation with no fractions or decimals whatsoever. So what we do with this is we have different terms, and like here's one term, here's a second term, and over here is a third term. The way we get rid of the fraction is we multiply each of these terms separately, even if they don't already look like a fraction like 1/2, and we multiply every term by the common denominator of all fractions throughout the equation. So in this case, this only has one fraction, so our common denominator is going to be a 2. So we are going to multiply every term by 2, which is 2 over 1. So this becomes 2 over 2, or just 1x. We'll rewrite it down here. I multiply this 2 by 2 and this 1 by 2. This becomes positive 4, and this becomes 2. Now I finish solving it. I have no more fractions. I don't need to deal with it. It doesn't mean that your variable can't equal a fraction, but it makes it easier to calculate. So in this case, our one step is to zero out the 4. What you do on one side, you do on the other. This has an x, and 2 minus 4 is -2. Okay, if you plug it back in, 1/2 of -2 is -1. -1 plus 2 is really 2 minus 1, which is 1. So plug it in to make sure that it works. Now what you're mostly going to get are things that look like this. Nice and big. So on this equation, we're going to look at everything that we have. I see a 3, a 5, a 3, and a 15. But I also see right here, this distributive property, actually the 6 and the 15 are all divisible by 3. I can take a third of these. So I'm going to eliminate a fraction right here just by doing that. So that's the first thing you want to check, is if your distributive property can be distributed. And also if this were something like 2/3 in here, I would need to do my distributive property in order to bring that fraction out of the parentheses and out of that distributive property, and then look for my common denominator. Okay, so in this case, a third of 6, or 6 divided by 3 is 2. So I have a 2x, and a third of 15, of positive 15, is a 5. So I still have a -2/5 x, a positive 8, a 2/3 x, a -11/15, and a positive 8x. Okay, so now I'm going to look for the common denominator. What I like to do is take the biggest number because I get there faster. I'm going to take the biggest number and see what I get to. So 15 times 1 is 15. It does 3. Can I multiply a whole number by 3 to get 15? Yes. Can I multiply 5 by a whole number to get 15? Yes. No more denominators. My 15 is my common denominator. So in this case, every single term, so I have 1, 2, 3, 4 terms over here, and 1, 2, 3 terms over here. Remember, a term is the monomial, or the item, that is separated by an adding or subtracting. So in this case, every single item needs to be multiplied by 15. So I'm going to multiply 15 by 2x and get 30x. 15 times 5, and this is positive 75. Now 2/5 times 15 over 1. You can either do 2 times 15, which is 30, divided by 5 times 1, which is 5, or you can cross cancel, divide by 5, divide by 5, and 2 times 3 is 6. But this is a negative, because there's a minus, so it's -6, still times an x. And again, 15 times 8. So if I do 15 times 8, I get 0, 4, 120, and it's positive. Okay, so looking over here, I actually just did my math, or use a calculator. So 15, so I have 30 divided by 3, or divide by 3, divide by 3, 2 times 5 is 10. times your x. I multiply this by 15 over 1, and I don't really want to multiply double digits, so I'm going to cross cancel. So divide by 15, this becomes 1, divide by 15, so this is really actually negative 11. And I get, that was a plus sign here, and I'm going to do 15 times 8, which I already know is what was it, 120 times an x. All right, now I have no more fractions, so I'm going to use the regular process. So I look for distributive property, I don't have any. I look on the same side of the equal sign, I do have terms I can combine. I have a positive 30x and a negative 6x. So 30 minus 6 is what, 24x. And then 75, positive 75 plus positive 120 is going to be 5, 7, 8, 9, 195. Positive 195, that's where I get the plus sign. Then I have 10x's plus 120 is 130x's minus the 11. Okay, now I have variables on both sides, so I need to move them to one side. I move the smaller one to make it so that I don't make a negative x. So I'm going to, when we move the whole thing, subtract it or add it. It's positive, make it negative, you need to zero it out on the side it currently is on. What you do on one side, you do on the other. Okay, there's a positive 195 that I brought down. This is, let's see, 3, 2, 10, 6, 0, 106. And this is a negative 11 you need to bring down. Okay, since I moved my x's to the right, that means I need to move my constants or my just numbers to the left. I need to zero out. So how do I take out a negative 11 by making it 0? I add 11 because that is 0. And what I do on one side, I do on the other. So this is 106x, and this is 206. And at the end, these is multiplying, but remember, my goal is to leave x there positive and alone. Since I'm taking a piece and this is multiplying, I'm going to divide both sides by 106. Okay, so I get 206 over 1 over 6, 106, or use the calculator. If we do 206 divided by 106, we get a really big decimal. So we're going to round, and it's approximately about 1.94. So x, remember, approximately equal to are those squiggly equals, about 1.94. And that is my answer. Or you could leave it in here, but you could also reduce this. They're both even. If I divide by 2, so if I do 206 divided by 2, I get 103. So that could be 103. And if I do 106 divided by 2, I get 53. And you could keep it like that if you would like. So you could say it's 103 over 53, or it's approximately 1.94.